Okay, great. How's everybody doing? Everybody full of coffee? Ready to listen? Get your phones out. You need them in 5 minutes, okay? My name is Mike, and the first thing we're going to talk about connected engineering. Does anybody know what connected engineering is? You'll find out. So my name is Mike Grau. I'm the technical sales lead for Synera. I've been quite a long time with Autodesk, worked in the automotive industry for a couple of years. So I have about 10 years experience in that field of computational design, and yeah, seen a lot in different roles, so I'm all for it. So today we're going to talk a little about low code, and what that is. And I want to show you 2 examples. They're unfortunately generic because of non-disclosure. But yeah, let's just go in. So a little bit about myself. I love to travel. So these are really the places I've been in the last 10 years. So I love to visit customers. I love to travel with my wife. I love to print stuff at home in my basement. So I'm really a tech geek. And when I have time, I build my own PV island solution at my home. So sometimes I get electrocuted. But yeah, a couple of house rules. Words off the list. No more generative. I'm not going to use that word. If I use that word, I drink shots tonight. So you can count. No lattice, no AI and ML. But I try to get around that today. All right, so a little bit about history about Synera. And that's a really interesting part of it. I found out about it about a month ago. There was a guy called Alfred Wegener, that guy, about 1912. And he was a guy I actually found out about who knows that? Plate tectonic, right. Unfortunately, he died in 1930 in Greenland in the ice, and nobody believed him that time. Well, 50 years later, everybody believed him, and everybody knows about plate tectonic, right? So the Germans were so kind, and I put a couple $1 billion into a research facility in Bremen, and they bought this really big icebreaker called Polar Star. So what this ship did is it went out to Greenland, Antarctica, and it took surface samples of the surface water. And what they found were really microbacteria. So first they ignored them, but a while later, they actually tested them, and they found out that their stiffness is much higher than anything that they've ever seen. And that was the inspiration to create the first tool that we call algorithmic programming. And that was pretty much the foundation of the company Synera. So, long story short, what is low code? And now you guys need your phones. Can anybody tell me if you ever heard about the word low code or grasshopper? So please, just scan the Slido's QR code and just type in your answer. I keep it open for a minute. No. Oh, wow, nice. That's what I was expecting. Okay. And who's winning? Grasshopper's winning. Alrighty, cool. Yeah. So I was expecting that. So anytime I mention the word low code, people say, what the hell are you talking about? And I really start to need explaining. Low code is pretty much connected engineering, visual program, algorithmic program, and you maybe know that from other companies in the industry who use a similar approach. We pretty much created a platform that allows you to program, but visually, with nodes and connectors, and that gives you a lot of freedom. So I created a little example for you guys, and that's really easy. I want to try to show you what that means and how that could inspire you to use it for yourself. So I'm creating a sphere here, and in order to control the size of the sphere, I create a slider. So I just set the minimum and maximum values. So the idea here is really to control the size of the sphere, but also control the meshing. So what that means is I'm building an algorithmic program right now. I'm programming visually. And you know that maybe from Antop, they have a similar solution, other competitors. But the idea is really not only limited this to CAD, expanded to implicit modeling, to FEA, to all kinds of technologies. ChatGPT, for example, Excel, whatever you have in mind, this is what you can do with this platform. So, oh yeah, this is where I screwed up, because I really need a divider. You see that the mesh is really coarse. So I had to put in a divider, another slider. So this is pretty much visual programming. This is what you can do with our software. And besides that, we have a lot of other nodes. We connect with all kinds of industry tools, OptiStruct, Hexagon Amidate. Pretty much, we're a friend of everybody. We're not competing. Well, kind of we do, but not really. I hope so. So what does that mean, evolve? When you look at a praxis example, this Ford pickup truck was in market about 5-7 years. And the development process of this front bumper bracket was about maybe 2 years, so that's what they get. But in reality, the developers or the designers, they maybe get 1 week or 2 weeks to redesign one of those brackets. And then it gets shipped to India, they mesh it, they clean it up, ship it back to India, maybe Malaysia. It goes around the world 5 times before they run the first FEA. So over time, you see that the time to market of these vehicles decreases, but their process never changed. So now they have a problem. Their process never changed, but the time to market actually decreased. So that means they really have to improve the process. They have to iterate faster. And the only way to do that is really combine disciplines, connect CAD with FEA, with everything else, with all the knowledge that's out there. So this is pretty much connected engineering. We have a platform that connects to all industry tools and all kinds of scripts, APIs that you can imagine. Right, so here's an application that I prepared for you. And just to give you some numbers, we created a CAD model with about 10 variables, so 2 million configurations. We ran a DOE simulation and trained an ML, first shot, okay. So the good thing about this workflow is it is connected. It took us 2 months to build it, but now we have it. We can use it for any other OEM. So we did it for OEM X, which I can't name, and used it for another OEM Y. But to modify that and adjust it to the next OEM, it took us only 4 hours. And then we could rerun the whole process in about 5 hours. And that is really the power of connected engineering. You only do things once. So all these repetitive tasks you do over and over and over, you pretty much automate them once and create a robust workflow. Another example is this additive drive shaft bearing. You see, for example, this really large workflow on the bottom, and it's much bigger. It's pretty much a mile long, but we automated all these boxes into modules, so they become inputs for you. All right, so what I want you to take home today is pretty much that we're a painkiller. We can be a painkiller if we're used right. And yeah. If you want to test Synera, scan your QR code, test it 14 days for free. Okay, the sales guy is coming out of me, I'm sorry. Yeah, but happy to be here. And now I want to hear your feedback. You can ask me questions, give me feedback, tell me I talk too fast, tell me I need to be more techy, whatever you want. So yeah, happy to hear from you. Thank you.